Welcome back to another F# video where we are currently looking at abstract classes, and we're going to compare these to interfaces today. We left off in the last video having defined an abstract base class here and a derived class that implements or inherits from this base class. We instantiated this derived class in the end and showed some of the functionality associated with this myFunction method, which is something that we inherit from this abstract base class. I want to take this one step further now, and I want to turn this abstract class that we had before into an interface. And after we've done that, I want to say a few words about the differences between abstract classes in F# and interfaces. So first of all, let's dissect the problem of how to turn this thing into an interface. The first thing I would say is all interfaces should start with a capitalized I to indicate that it is an interface. So let me just make this change of notation. Let's see, I base, like that. Okay, that should not change any functionality, but just because we're turning this into an interface now, we should use the convention that's sort of commonplace in F# to begin with a capitalized I. Second thing we want to do is remove this abstract class notation, and you can see now that we're going to start having some errors. We get an error because F# still thinks we're trying to create an abstract class here, and the reason for that is we have a parameter being fed into this. Now, for interfaces, you're not allowed to create a constructor with those, so this one needs to go, meaning we need to remove this parameter1 input to the class. Now, you're going to see that as we remove this, the second line here breaks, and this is where we're trying to set a member value for this, what used to be our abstract class. For an interface, you can't have these members, so we need to remove this sort of functionality, and I'll just do that real quick. And you can see that in the derived class, we used to inherit this parameter1, or we used to inherit the constructor rather of the base or the abstract class, and thereby we would get an initialization for the parameter1. Now I'm simply going to do the same as we're doing for parameter2 here and just copy over the definition that we had, like that. Okay, now the next thing, before we move on now, let's think about what we did. So we had a member in the abstract class before, and because we now turn this into an interface, we're not allowed to have these members that would be initialized through a constructor. So we had to remove that. And then I just implemented the corresponding parameter in the derived class here because we still want to provide these two parameters as input when we initialize the derived class. So far, so good. The problem now, as you can see, is that the myFunction implementation here doesn't work. And the reason for that is we're trying to override this value, but this is not how you extend an interface. So if you're implementing an interface, you would write this slightly differently. So the way we're going to rewrite this to actually indicate that we're extending an interface here is we're going to say interface, and then we're going to provide the name, so ibase, like that, with keyword, and then there we go, member, and then we can say this myFunction and then just give the implementation. So you write it slightly differently. Rather than an override statement, you would say interface ibase with and then this function here. One thing to note is all the members that we define up here in the interface need to be inherited in the function down here. Okay, now the next thing that it complains about, and we're almost done now, but the final thing that we need to amend is we're trying to access derived class.myFunction here. But this interface call actually requires us to cast our instance of this derived class into the interface class. So the reason why it complains here is because we're trying to access myFunction on an object of type derived, but what it says is the type derived here doesn't have a myFunction. The thing that implements myFunction is the interface. Now, granted, we give this implementation here, but the reference to this is still on the level of the interface. So to be able to make this call here, we need to cast this thing that used to be derived into the interface type. And we would do that using this character here, and then we would simply say ibase, like that. That turns it into the interface class and makes the myFunction available for use. Now, it's still going to use the implementation that we gave it in the derived implementation here, but we need to have it of type ibase in order to be able to access that function in the call down here. So we have no more errors, and just for reference, let me execute this so that you can see that we still get the same output of 7 that we got when this was an abstract class. And I want to say a couple of words now about the differences between these. So the abstract classes and the interfaces in F# serve quite a similar purpose, but they have slightly different implementations and use cases, and that's what we saw now. So we saw before that we could define a member here in the abstract method and initialize that with a constructor immediately, and then make use of that in an inheriting class. And so you can create partial implementations, let's say, in the abstract-based classes that help you initialize some values immediately. With an interface, we're not allowed to do that. Here we simply provide signatures of different functions, and we force anything that implements these to extend all of them. So if I had another abstract member here, my function 2, let's say, and I wanted to implement the interface in this derived class, I would need to provide both of these, or implementations for both of the methods from the interface. So the interfaces are a bit stricter in that sense, in that they just provide a very formal template that needs to be followed by all classes that extend it. So if you have something like that, a very strict sort of schema that you're trying to follow in the methods, then an interface would be probably what you're going for. If you have, on the other hand, something in between, where you want to be able to provide member values already on the base class level and then use those in the inheriting classes as well, then an abstract class would be a better option. So that's really a design choice that you need to take into account depending on what kind of implementation you're making. But those are the main differences between interfaces and abstract classes in F#.